Today I will be taking the problems on nodal analysis with dependent sources. So in the last class there was a doubt that what is a supernode? Okay. So while studying mesh analysis we studied what is a super mesh. We cannot apply mesh analysis in loops which contain current sources. So if we come across a current source in a mesh, we group together two meshes excluding the branch containing the current source, and we join two meshes together and we write the loop equation without the current source. Likewise, here we have by considering the super node, here see this branch. In this branch there is a 6 volt source in this branch. For this particular branch we cannot write the current equation. Okay. For that we take these two nodes together and make it as a single node and write the KCL, and this concept is called super node. So you will explain it better while we are doing this problem. So here the question is, for the network shown in the figure, determine the voltage Vx. Okay. So what is Vx? Vx is equal to V2 minus V3. Vx is equal to V2 minus V3. Okay. Here we have three unknowns, V1, V2 and V3, and Vx, which is V2 minus V3. So to find Vx we have to find V2 and V3. So we will begin with the Kcl equations. So considering node 1, we cannot write the Kcl for node 1 alone. So we can combine these two nodes to write the Kcl. So Kcl for node 1 and 2. Kcl you can write it as -2 plus V1 minus 5, that is plus 5 by 4 plus V2 minus 2 Vx by 10 plus V2 minus V3 by 11 plus V2 minus 8 minus V3 by 7 is equal to 0. This is equation number 1. Okay. So now next we need 3 equations because we have got 3 unknowns. So now we will go for KCL at 3, node 3. KCL at node 3. V3 minus V2 by 11 plus V3 plus 8 minus V2 by 7 plus 12 is equal to 0. That is equation number 2. And we need one more equation. What is the third equation? Third equation we have V1 minus V2 is equal to 6 volt. V1 minus V2 is equal to 6 from here. That is equation number 3. So here we have 3 equations. By rearranging the first equation, we can write it as 0.25 V1 plus 0.133 V2 minus 0.033 V3 is equal to 1.89. This is the rearranged first equation. And coming to the second equation, that is KCl at node 3, we will get it as minus 0. We can write it as minus 0.233 V2 plus 0.233 V3 is equal to minus 13.14. So here we have the second equation rewritten. The third equation, there is no need of rearranging, and we will get V1 is equal to 1.8 volt, V2 is equal to minus 4.2 volt, and V3 is equal to minus 60.6 volt. Okay, here the question is find Vx. Vx is equal to V2 minus V3, that is equal to 56.4 volt. This is the answer. So, hope you understood. If you have any doubts, you can ask me. Here we have the second question. Find the node voltage in the network shown in the figure. So, here we have unknowns V1, V2, V3, V4, Vx and Vy. So, by looking at the circuit, we have a 12 volt source here between V1 and ground, and the negative of the 12 volt is connected to V1. So, we can write V1 is equal to minus 12 volt. Okay. And we have Vx. Vx is between V1 and V2. And Vx, the positive of Vx is at V2. Therefore, we can write Vx is equal to V2 minus V1. Likewise, you should write what is Vy. What is Vy? Vy is equal to V4 minus V1. Did you all get it right? Okay. We'll move on to the next. Next, we have to write the Kcl equation. So, we have already found V1, so we needed to write Kcl for V1. So, we can write Kcl for V2. Therefore, can we write V2 minus V1 by 0.5 plus V2 minus V3 by 2 minus 14 is equal to 0. That is the equation number 1. Next, V3 is the next node. Can we write the Kcl for V3? No, because there is a voltage source coming in this node. Therefore, we cannot write the Kcl as usual. So, we take these two nodes, we can combine these two nodes together. So, we can write the Kcl for the super node V3 and V4. Kcl for super node V3 and V4. That is V3 minus V2 by 2 minus 0.5 Vx See, this is the current directly given. There is no resistor or anything given. This is a direct current. That is why we have written it as 0.5 Vx. Here we have to find the current. That is voltage difference by resistance. That is voltage difference by resistance. Here the current is directly given. Therefore we can write it as 0.5 Vx. Next, it is flowing into the node and therefore we have put a minus sign. Next, V4. V4 minus V1 by 2.5 plus V4 by 1 is equal to 0. This is the second equation. Okay. Here we have got 4 unknowns, of which V1 is already known. So we have got V2, V3 and V4 with the 3 unknowns. We should get 3 equations. So we have got 2 equations already and we have to get the third equation. And what is the third equation? Third equation is V3 minus V4 is equal to 0.5 dy. Okay. So we can put the Vx and Vy, Vx values as Vx as V2 minus V1 here. And what is Vy? We didn't write Vy. Okay, here it is. So we can put this Vy over here and Vx as this. Okay, Vx is V2 minus V1 and for Vy we can put it as V4 minus V1. So we can rearrange these equations 1, 2 and 3. Equation 1 can be rewritten as minus 2 V1, 0.2 V1. You can write it as minus 0.2 V1 plus 2.5 V2 minus 0.5 V3 is equal to 14. This is the rearranged equation 1. And equation number 2 can be rearranged as 0.2 V1 plus V3 minus 1.2 V4 is equal to 0. And the third last equation, you can put this Vy here. So this is equation number 3 rewritten. And next, coming to equation number 2, we can rewrite it as 0.1 V1 minus V2 plus 0.5 V3 plus 1.4 V3 is equal to 0. And this is equation number 2 rewritten. And we have got all the 3 equations and 3 unknowns. We can find it as V1 we already know it's minus 12, V2 is equal to minus 4, V3 we will get it as 0 volt and V4 we will get it as minus 2 volt. And we have found all the node voltages, and I hope you understood the solution, and if you have any doubts you can ask me. Sorry, in equation 1 it's not 0.2, it's 2.